Bill Beisel has agreed to join me again. He was warned against it, but somehow he overcame all of those warnings and said he'd come back on the show. How you doing, Phil?
I'm doing well. I like the shirt.
Thank you so much. It's a thing. It's a thing.
While
Um,
it's cloudy and rainy in California, right?
Up here, up north.
It's cloudy and rainy here, north. Yeah,
Yeah, you're in north.
that's
Yeah, I'm in
that's right.
south. I'm looking at sun.
Oh, you're looking at sun. Okay.
We don't have any. We have no rain in the forecast.
I
You guys are getting it all.
think you need some.
But you can send it down. Apparently, President Trump found a way to get it from
Oh, right.
California to Southern California. Who knew? Who knew?
Who knew this was possible?
Some canal or something. I don't know what.
Yep.
Yeah, whatever. Okay, so listen, we were talking in the green room, and you were talking about something that has been near and dear to my heart for a few weeks now. Been talking about it a little bit, and you were just talking my language. I thought I'd let the crowd hear it from somebody besides me. So let me see if I can frame it. Wall Street analysts have to know about a ton of stuff. If they've got the entire auto industry, they got to know all the foreign makers, the local makers. They got to know the histories. They've got to know. They got to try to get the information inside what's going on. They've got a ton of stuff to know, but it's all in that auto industry, and it's something they're really, really familiar with, and it's 100-year-old industry. They get it backwards, forward, inside out, and they're still probably wrong most of the time. But at least at least it's something really within their grasp. You were using the example of a Walmart or a Costco or a food store. We know about food stores. We shop in the stores. We got an idea, and it doesn't take much to learn about distribution systems and whatnot that may impact pricing and straightforward stuff. But then you were talking about this DeepSeek thing last week as everybody's panicking over whether open AI is now worth nothing, whether Nvidia needs to take a 10% haircut. Talk to me more about how you
Yeah, I mean, a lot of this just comes back to, the Wall Street guys good with their spreadsheets, but I mean, AI is just a different thing, right? If you think about um, my years in engineering as a software guy, I don't know many Wall Street guys that ever even understood software, right? And if you take a look at AI, it's sort of at that next level of complexity to try to, it's not um, until you build a model in your head, it's not intuitive to
Right.
what how it works,
Right.
right? So what they do is they tend to just pretend they know how it works. Or a good way of thinking about it is because it's such a black box, they kind of just zoom out to the top of the black box and say, oh, it's just these two things.
Yeah.
And so, therefore, DeepSeek looks like it reaches parity with OpenAI and at whatever 10x less compute or whatever the whatever they think. And then now there is no Nvidia. Like Nvidia will never sell another chip again, type of thing. Um, or another example was when Jensen spoke at CES about he was talking about like this SDK that they were building for self-driving, right? That they could train. They were talking about
Right.
robotics, and in this case, in the four-wheel robotics camp, they were talking about, okay, we can now synthesize data, we can do this, we can do this, and therefore, there's no value to Tesla FSD because all the competitors
That's
immediately.
not what Jensen said.
Yeah, yeah, it's not what he said. I made somewhat of a cynical remark about it online, which got a lot of traction and some complaints that I said it's a great way for Nvidia to go because what they do is they sell chips to Tesla. Tesla does some really first principles work, creates a solution that serves their purpose, but everybody else wants. Now Nvidia comes in and builds a framework or an SDK for that type of thing. and everybody is seduced into the idea that if they just buy a bunch of chips, um, they can just turn around and create FSD. And then think about that process: rinse, wash, repeat with
Yes.
Optimus or whatever. Um, yeah, I mean, it's sort of interesting because it it just is insane listening to these Wall Street guys try to pretend that they understand, draw conclusions, throw the baby out with the bathwater. And as we were talking earlier, the DeepSeek thing, the idea there was we'll never need as much NVIDIA compute. And I wrote this post. I was like, no, it's actually the opposite. Like, if you're in the software business, you know it's the opposite. You know that now um, suddenly the world has got more competitive, not less competitive in the space. You know that if a software engineer can do something with 10x less of a resource, now he's going to demand 10x more of the resource to do even more, right? This is just reality.
Yeah, yeah.
And having done all this stuff in my professional career, I'm like looking at this going, the DeepSeek, like I literally woke up and saw that and thought, stupid me. NVIDIA would be on the rise because they would see that the space is even hotter now.
Right.
And the market reacts as, no, it's cold.
Well,
Uh,
so in my own sphere, I've developed hundreds and hundreds of products over the years, but they've been simple products. They've been bicycle products, are related to the bicycle world, demand specialty or whatever, simple stuff. And even then, people that are not in my space know far less about it than I do. That's just natural, right?
right,
You
of
become
course.
an expert in what you do. So, so 3 months ago, 4 months ago, 5 months ago, when Nvidia got hot, and we started talking, everybody started talking about Nvidia, and I thought, well, should I get invested in Nvidia? So I started, I spent a couple of hours listening and paying attention, and a few more hours, and finally, I just said to my wife, I said, I'm not going to get invested in Nvidia. There is no way I'm going to be able to understand Nvidia. I'm not going to
Ah,
be able to understand whether or not. And
right.
I've had these conversations with Brian Wang and with Larry over and over again
Mhm.
because they're experts in software and experts in that area. And it's like Brian says, no, there's no limit to the compute. As much compute as you create,
Yeah.
they're going to want more in order to solve bigger and bigger problems and solve them faster. And I'm like, okay, I get it, but I'm not willing to bet on it, even based on Brian Wang saying it, because I don't understand it.
Yeah. It, it's a good point. I mean, I think that when I think about the stocks I own, I'm super deep in understanding, but that's my brain. I mean, that's how I operate anyway. It's funny. I have a similar kind of trajectory here with Nvidia. I had bought some a while ago, like years ago when I worked at Rivian, because I kind of understood a bit of their trajectory in accelerated computing, but I didn't do anything with it. Like that wasn't my task. I didn't have any tasks, any type of engineering work or teams that did AI stuff at the time,
Mhm.
you know. So AI was sort of a newish thing to me. And I wrote this paper, article, which everybody could read called Accelerated Computing, which kind of goes really deep. And the the hidden secret about that article is I did it to teach myself, like what's going on here, like
Yeah.
where's the huge advantage, and I learned so much. Like I just said, let me look at state of the art CPU. Let me look at the math involved in the AI training and inference side. They're sort of the same, but slightly different. And let me see how the CPU and the GPU products are different in terms of how they get to the finish line.
Right.
And I mean, okay, the obvious thing is it's great parallelism, but uh, how do they achieve that? How is it that a CPU will never achieve that? So I wrote this thing, and it made me comfortable at the end of that saying, okay, I totally understand what NVIDIA's advantages are. in terms of not only the silicon, but the framework, CUDA framework on top of it, which is sort of important because a lot of times you hear people say, well, their AMD is going to show up and, and other people, it's not like you can't make a neural core chip. I mean, every one of our Teslas has one, right? So, but Nvidia has taken that to extreme levels, and they've understood the trajectory of the market. From the early. I mean, obviously they started as literally graphics. I mean, we still call them GPUs, which is crazy,
Right,
right?
right, 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 right.
And in a sense, the next big opportunity for them was um, Bitcoin, like mining
Mhm.
that type of compute. And then we moved into this AI field, which really, um, like all the math in AI is incredibly simple, but there's a lot of it.
Right.
So yeah, like Vic, I think in that paper I said if you trained Chat GPT, I don't know, it's like quadrillion matrix multiply operations. Quadrillions, like
Yeah.
so quadrillions. And one inference just to ask like a like a a 5 word prompt is I don't know, a couple hundred million matrix multiplies. So so I, I pulled back that thing to try to understand where their advantage is.
Right, right.
I've done that with Tesla as well. And then to kind of full circle this, and I think about the guys on Wall Street that make comments, and I'm like, how are they? I mean, you can have a very smart person intuitively grasp sort of at the surface and kind of
Yes, yes,
and
yes.
draw the right conclusions, I might add.
Sometimes.
Like kind of they say, I get it,
Yeah.
see what's out there. But my brain can't do that. I'm not that smart. I need to go much deeper into the tech itself, reverse engineer it out, and then say, okay, I see where the advantage is or the
And you have a computer science background and you're an engineer. You take Randy, who is a law school graduate and a plastics manufacturer who has, I've had to use computers a lot, but then I'm starting, multiple layers below you. And I'm going to say that some of these Wall Street guys are starting layers below
yeah,
me because they maybe don't have the real world experience of putting together a computerized system for a factory to, you know, do inventory controls and to,
right.
count
Yeah, I
atoms,
mean,
you know.
the engineer brain has to do it to understand. That's just like that's the flaw that is embodied in me. I have to do it to understand it. Otherwise, I don't think it could be understood. Um, and I had this thought maybe it's got to be at least 20 years ago as I started investing in stocks or whatever. And I thought there's going to be a point where analysts, I guess would be the right term to their behavior or their job title,
Yeah.
are not going to understand what they're talking about. Like,
Yeah.
I mean, okay, that's kind of funny because I think we all say that a lot of times they don't understand what they're talking about. But I mean, like, really,
Really
the
do
subject
understand.
matter has gotten so technical
Right.
and so beyond
Right.
scope that, like, really, realistically, do you think someone can analyze, like, well, does AMD really have a competitive product and how would it show up and who's going to use it and can it get traction and are the software frameworks there and, all that stuff. Um, Tesla FSD is my favorite example of that because I think it's like what you constantly hear people saying, um, I could just pour driving data in one end. And we've recently heard synthetic driving data in one end, right? So now you don't need a fleet of cars apparently. And then out the other end, I just get something that drives.
Yeah.
And I'm
Yeah.
like, well, you haven't described a single facet of the model you're building, like the AI model. So if you think of a model as a big box of magic numbers, right? I mean, like a neural network is
Yes, I understand.
these layers. Um, you kind of have to understand. what are your inputs and what are your outputs? And if you start to pull that back, you say, well, what, ask someone who's thinking about full self-driving, what did they train? You know, and most of it lands on, in full self-driving, there's really kind of two pieces of it. There's perception and planning. And perception is perceiving all
Right.
the physical space and building like a vector map of everything that's in front of the car and the cameras and so forth. And then planning is like next level hard because that's using all that information and building a plan for the next fifth of a second as to
Right.
what the car is going to do. And if you ask somebody, well, okay, so you had data and you built them up, what are you training to build a plan? What is your, because I actually at the end, what you're doing is you're actuating controls, accelerator, steering,
Right.
angle, brake, and you can simplify and say, well, I poured in driving data and out came the magic answer as to whether I should accelerate the car or or brake or that's not good enough, right? I mean that's like saying nothing. That's like saying I understand how a microwave works because I put something in and I hit 1 minute and it came out hot.
It came out high.
Yeah,
So I think you've kind of tripped something in my mind, which is, that Elon last week was talking at the earnings call where he said, well, in China, because we don't have access, because they won't let us train uh, on their roads, we can't use the data to train. We're just grabbing YouTube videos off the internet in order to get that training done. And I think people, I saw many, many comments on X and a couple of articles, a couple of people that are writing articles saying, oh, well, gee whiz, why can't everybody do that?
yeah,
And I thought to myself, well, because you haven't done all the other underlying work.
right.
You haven't created those magic
Yeah.
formulas. You haven't created a planning system. You haven't run the possibilities a bajillion times and pushed the data back on itself to make sure that it was working. You haven't tested it for millions or billions of miles.
Well,
And now all you have to do in China, I think, maybe, help me out if I'm wrong. All you have to do in China now is take the specific things that you don't have on American roads, and that's what you're grabbing from those YouTube
yeah,
videos, the
I think
differences, and apply that to the bigger framework.
what I took away from that was so one of the AI days that Tesla had, they talked a little bit about their driving simulator.
Mhm.
And so, you know, I think we kind of put this in the box of synthetic data. So they showed a video of like a San Francisco intersection, market and something. And that it has a certain configuration. And what they showed is that they can augment that configuration drastically. Like they could make it snow or rain. They could add they could they could take out traffic lights and replace them with stop signs. They could add crosswalks, delete crosswalks. They could delete lane markings so it was kind of amorphous. They could put in hedges,
Mhm.
or they could remove hedges to see, oncoming traffic. And so what they were doing is they were taking a scene
Mhm.
that was real, and they were then using demonstrating that they could augment that scene so that they could now train the system on more use cases that were not available to them, in the fleet, in the data, natural data.
Right.
So I think we're in the same place here, is that we're saying there's certain configurations like whatever these YouTube videos are. Um, I suspect what Elon is trying to say here is we're looking at intersections and roadway configurations, and we're then turning around and configuring our simulation um, or simulator
Right.
to build synthetic data to train on those types of situations. Because the problem is, I guess, that China prohibits having that data come back to train at the main
Right.
on what is it? Is it Cortex? Yeah.
The Austin Cortez. Yeah.
Yeah. In other words, they can't bring that natural data back. And there's always been a question of mine, like how they take the principal model and they augment it even through versions, right? That's sort of fine tuning the model. So, like I suspect that what they could do is they could take the natural model for say version 13, some base level,
Mhm.
and then bring it into a Chinese data center, train on the data there just fine, like because they don't want the data to move.
Right.
But I think that they're saying, oh, we have a way around that. We'll just look at complex configurations of roadways and scenarios like maybe you've got, you know, 10 lanes and you've seen some crazy,
Mhm.
10 lanes, 10 lanes, and there's no traffic lights and people just, it
Right.
just kind of floods through. Um, and so maybe they're just saying, oh, we have one of those. Let's build a
Right.
simulation for it. Um, that's what I think's going on there.
So
Yeah.
we start. The reason that we even started the program today was because you'd sent me a note talking about Lidar,
Hmm.
and I said I thought that this instead of starting with Lidar, we would end up with Lidar because I think
Yeah.
everything that we've just said
Yeah.
kind of comes back to the conversation about Lidar. So we have a bunch of technology and or automotive analysts on Wall Street who keep saying, you're never going to be able to do this without Lidar, and these other guys all use Lidar, and then Waymo says, well, they used to cost $5,000 a piece, but we can get them for $500 a piece now, so now it makes more sense. And Elon says, I don't care if they're free, I wouldn't put them on my cars. So,
Yeah.
so
It's
there's a tremendous amount of, I would call it, okay, here's this top level knowledge of these guys that don't know anything on Wall Street that are just throwing it out there. Then you got a next layer of people that have been kind of paying attention that are saying, well, gee whiz, Waymo says this and da da da, but they don't really know. They don't even kind of know how LiDAR works or what it's good for or what it would do that the vision can't do.
right.
And then you've got you who's sitting there going, but wait a minute, even if it gave me some extra information, I got to put it into a computer. And the computer's got to be able to what?
Yeah, synthesize it or fuse it into the decision framework. Yeah, I mean, so um, this is a really interesting topic, and there's a lot of places to go with it. But it starts off with the premise, I think, is that um, full self-driving is such a black box because of all the stuff we've talked about, the fact that AI is pretty opaque to most, um, that now people are just teasing the top of it.
Right.
And they're saying it's clearly safer if you add another sensor. And to that, I say that's crazy. I mean, and here's why, right? So first off, let's look at the sensor. What does it do? Um, what problem is it solving that the other sensors can't? So if we look at Tesla today, believe that the Tesla full self-driving system is 8 cameras, two forward, two rear, and then there's the ones on the pillars. And then of course what they're doing is in some version of 13, they're going to bring in audio for detecting emergency sirens.
Right.
Okay. And then it's a hard stop. There's no other sensors being used. Maybe the IMU for like determining just inertial stuff, like, like if you're trying to take a curve with the car, how much G force would you
Mhm.
have that makes it comfortable
Mhm.
for somebody, right? Even though the car may very readily be able to take it at a higher rate of speed, it may be something where, most people wouldn't
Right.
think that that's safe or whatever. So, um, if you take something like LiDAR and you look at, so this is the LiDAR is a radar system using light, visible spectrum light. Um, and what's and it's coming in at a fairly fast rate. And what it's good for is mapping the physical environment around it. With this, so if you think about what the cameras are doing. The cameras are doing the same thing in the perception side. They're building a vector space of all the objects. And when I say vector space, it's important to understand that, every object would have a label to it, and then it would have like a direction and a velocity. So like a stop sign would have direction, like it would have a location,
Mhm.
would have no direction, have no velocity. But other things would have direction or velocity, like a pedestrian, bicycle,
Right.
other car. So what the thought here is that what the lidar can do is build you a better picture. Now, can it? Well, first off, it's light, so you hear a lot of people saying, "Well, the cameras are going to be in trouble in fog, snow, rain, so we'll throw in the lidar." And that's not true because lidar, which emits light, uh, it reflects off those surfaces, right? Those are physical objects that reflect. I mean, after all, that isn't that the point of what lidar is doing? It's trying to reflect off a surface to give you a sense of where that thing is.
Sure, sure.
So you call that scatter when it hits a bunch of raindrops. I mean, it's giving you accurate, probably data, but you don't know it's rain,
Right.
right? So it's not good for certain types of things. Now, how Waymo is applied it is in a very, to my knowledge. Now, again, there's a lot of secret sauce in these companies
Sure.
that is sort of, so sometimes it's told, sometimes it's more folklorish.
Mhm.
You have to kind of tease it together. You're not sure it's what, but the essential idea is that Waymo is doing kind of a map matching model with the lidar, and that they're saying, okay, in San Francisco, I know these roads using what people would call high def maps.
Yeah.
So the difference between a high def map and a map that you would look at visually is high def maps are all the vector space. They don't look like visually something you can
Right.
uh, easily understand, but there's more data there.
Mhm.
So, and the high def maps have more elements to them. Like in certain cases, they literally have, the complete measurements of the road surface, where the white lines are, where the dotted white lines are. I mean, specifically
Right.
inch by inch,
That's-
and so forth. And so, what they're trying to do with the LiDAR is they're trying to match it. So the idea would be that um, it's like a person in a dark home that is familiar with their home, and they're putting their hands on the walls, and they know the walls, right? So they can get to the kitchen from the living room so they're sort of doing this process. And of course, what what uh, what LiDAR is doing is it's emitting light, so it works well in dark as well because it actually is the source of its own light.
Right.
Um, but what FSD is doing is different, is it doesn't know the walls. It doesn't know anything about that room. It's like as if you entered your neighbor's home and tried to get to the kitchen
Mhm.
from the living room
Right.
in the same particular way, right?
I got it. Yeah.
So what I'm basically saying is the problem with LiDAR is that at one level, the problem with LiDAR is it doesn't solve a lot of problems that people think it solves.
Mhm.
That's kind of one basket of problem.
Mhm. Mhm.
Um, the second basket is that in terms of FSD, the technique that FSD is using is not to map match
Mhm.
at all.
Mhm.
So in that particular technique, that way of doing thing, LiDAR doesn't assist in that particularly. Although it could assist in the general perception space, no doubt about it, it could. Um, and then you've got this problem of, I call it the engineering, long tail problem. So and here's where I think it is actually, this is where the devil's in the details. Okay. I mean, maybe that's the way to say it. If someone said to you, just add LiDAR, everything will reveal itself, everything will be better, you have redundancy, you have backup. Um, okay, let's go down that path a little bit. So now you have different sensor modalities, right? So you have a LiDAR, you have video or a camera, and you could add into that radar if you want. And now you have to have a process called fusion, where you have to decide. this is sort of a engineering question. Do you do what's called early fusion or late fusion? So early fusion is that you're taking the raw data from the sensors and you're essentially adding it to the processing pipeline, like as it comes out of the sensor with no pre-processing.
Mhm.
Late fusion, um, your processing pipeline for that particular modality, sensor modality, is okay. Try to make some meaning of this, and then inject the meaning into the stream at the end. So you got to make these decisions. Do you do any pre-processing on the data as part of your um, pipeline and late fuse it to early fuse it? Regardless of what path you end up on, now you've got to kind of make some decisions as to who is the ground source of truth. And that sounds super easy because it's just redundant, but what does that mean? I mean, if the camera is telling you one thing and the lidar is telling you another thing, is the lidar the correct thing? If so, get rid of the cameras.
Right.
If the lidar is always correct and the cameras are suspect, then what's the point of the cameras, right? So that's clearly a very, very deep engineering problem, and it takes a lot of effort to try to figure out whether it's radar or lidar or any sensor. How about this? Even the number of sensors, the resolution. So if you take the cameras, placement of cameras, resolution of cameras, frame rate
Right.
of the video, light sensitivity, right? Do you go with the raw capture of the photons on the digital surface, or do you pre-process them? Again, it's a fusion issue. So, you know, Tesla has figured out a plan for their cameras, and they're very comfortable with that plan. And what they've discovered is through sort of the what I'll call the Elon engineering process, where, you know, like let's simplify the requirements. Because at the end of the day, Randy, so when I was in computer science back in college, I had this one professor, and it was actually a robotics course, which is kind of funny considering where we are today and how old I am and how much space is in there and what we were doing. But he's a funny guy. But what he wrote on the board the very first day was he just literally went up to the board. He says, "If you learn one thing in this class," he just wrote "kiss"
Yeah. Yeah.
and keep it simple, stupid.
Yeah.
And he said, just let that stick in your brain for the rest of your life, like as an
And
engineer.
it's worked in my case. I have stayed simple and stupid. You
it
know,
it yields a lot because what engineer and if you think about Elon's what 3 or 4 step process,
yeah,
he
yep.
kind of it is sort of like teasing out what keep it simple stupid means
Yeah.
because he's saying like simplify the requirements, don't optimize until you know what you're building, delete things until you feel the need to put them back, like you've deleted so much. No, this is, and then at the end you can automate the process, right? Whatever the process is, and and if you realize how Elon got there, it wasn't because he's just you know handing the Ten Commandments down. It's through his own personal engineering failures that led to building a framework to avoid them. Now, what's interesting about what he tries to do there is it's the hardest thing to do is to follow that plan. You always have this thing as an engineer, if you're specialized, and I want to come back to that in a second about LiDAR. If you're specialized in an area, you go deep in that area, and when you come up, you've done a bunch of stuff, and you're like, well, how does it map to the requirements? I don't know, but let's map it to the requirements because I did all this stuff.
Right, right, right.
Right. So imagine that you're building an
They all seemed
organization.
important. They seem important.
Right. So imagine you're building an organization where you determine that LiDAR is something that you're going to put in the product. You need it. You've decided. So now you're going to go out and maybe hire some engineers who know a lot about that. And they're going to sit in some space in the office and they're going to go deep on that. And they're going to kind of deliver their LiDAR package. And then the next part of it is like some kind of large system integration to try to determine, okay, the camera guys are delivering their processing package called part of the pipeline, processing pipeline of the input stuff. And before you know it, the problem is there is no single person in the organization that knows enough about the whole system, right?
And everybody is a champion for their particular way.
Yeah, and yes, it's human nature is that they built it, so they got to put it in there, right? They may have built something that isn't required, but they really want to put it in there, so they'll advocate it in a way that seems genuine, seems altruistic, but really fundamentally it's not because they don't advocate for their own demise, right? Like I don't want to use Lidar, so okay, cut off what I do. So what I think was happening with FSD is that Elon was trying to drive that process very deep into the organization and tell his team, if you need this stuff and you can prove you need it,
Mhm.
then it's in.
Mhm. Mhm.
Um, but otherwise we're deleting it.
Right.
And I think, he pushed them very hard, ruthlessly, to examine why you might need these things,
Right.
LiDAR or radar, and decided on balance we don't need them. It adds complexity. What I think that they're trying to lean on is let's have the simplest input mechanism we can adopt,
Mhm.
with some facets that are, like really good light sensitivity, a lot of, redundant. There is redundancy. There's multiple cameras. People forget
Right.
that. Um, and then, let's build this safe system
Mhm.
um, through the AI model, um, and let's put our expertise in simplifying the input sensors and then the AI model itself, right? If people want to complain about FSD, they should really focus on this. They should ask more questions about the AI model,
Mhm.
frankly, not the sensors. But again, here we are. We full circle. We come back and we say, uh, "I'm a Wall Street analyst. It's clear to me if you add another sensor, it's a safer system." And if you tease out all the engineering processes, decisions, and the stuff I just talked about, you end up with saying, "Is it? It's not following the KISS principle." Um, and yeah, so that's why I think I would attempt if someone asked me, and I'd say, "Well, let's try the simplest amount sensor inputs possible. Let's do the simplest model. Let's have the simplest control actuation. Let's not get too fancy. Um, and then let's focus on scenario." And so what I mean by that is where you really want to go deep is trying in test um, through fleet data and simulated synthesized data, all the possibilities. For example, um, test and train on sunlight, including camera one,
Right.
um, from this angle,
Mhm.
and see how we degrade functionality and do we, right? And so it is incredulous to me to hear people think that they haven't thought this through. They've got an incredible AI team.
Yes.
They've thought about think about every time a version is released, I can guarantee whether it's 13.2.6 whatever, um, I can guarantee that they are running that through a regression test framework with millions upon millions of test cases,
Right.
including additive ones that it is meant to fix, or you know,
Mhm.
uh, all the old ones that they had before, and some other scenarios. And so they're proving to themselves. And so, what's interesting is one of the things that you hear constantly out of them is, we think it'll be safer than the human at some level, and whether you consider Elon's words optimistic or whatever, it's very clear that what he's saying now, because we see convergence, right? Like there's two versions of Elon here, frankly, and people confuse the two, and I don't, because I can see this. One version is just the optimistic guy that he is. Like actually, a lot of engineers are actually, some are somewhat pessimistic. Nothing will work. Everything breaks. But some are just optimistic for like future outcomes, like the thing that they're building. And Elon uh, genuinely is that person.
Yes.
But then the other time he's optimistic, which I'm starting to see now, is that he is telling you about a future state that he already knows about. In other words, there are several versions ahead in the lab, and he's seeing the data. Because remember, if I ran it through test framework, I probably build a score.
Mhm.
And if I built the score, I might see that that score has gone up
Mhm. Mhm.
linearly, exponentially to some place, and then I might tweet about it,
Right, right,
when my team
right,
tells me, I might tweet
right.
like, wait until you see what's coming. And people say, oh, it's just Elon, and but I think what's happening here is this is a different scenario. He's seeing the convergence,
Right.
and he's looking at it and he's saying our scores are better,
Right.
internal scores,
Right.
and that's because it's to him it's a current version. To the rest of us,
It's a
it's like he's predicting the future, and we don't have access to that version. So yeah, I think that's a loaded.
so then if we bring it full circle, and this is not investment advice, although in a way it is. If you're going to be a stock picker, to me, this is just me. What do I know? I've been a stock picker since I was 20 years old. As a stock picker, to me, the wise thing to do is to go super deep on the stocks that you're going to pick. The saying that you can't beat the Wall Street guys, how can you possibly? They can trade faster and they've got algorithms and they've got computers that are
Right,
making all these
right.
predictions and stuff. You can't beat Wall Street. The only way that I know of that you can beat Wall Street is that you have to be more knowledgeable. You have to have a what I call, the knowledge differentiate. That's not the right word. What's the word I'm looking for there?
Well, I
Arbitrage,
think
knowledge arbitrage.
yeah.
You have knowledge that they don't about what's happening, what's going to happen, and you can make your stock pick based on that because they can't possibly go as deep as you can go if you choose to spend the hours. And a lot of you are. You're watching this video. If you're watching this video, you've just devoted 50 minutes to becoming smarter than Wall Street. So this is why I do the channel, quite frankly.
Yeah, I think like I think equities are great. And I own few of them, and the ones I own I know a lot about. And I don't know maybe as much as I should about the financials, but I know more about the company's product trajectory.
Right.
And to me, that's all you really need to know. Like I don't really care day to day, like quarterly. Oh, they showed up with 1,000 less cars and sold. What is that? That's noise, right? And then 2 days later, the market has absorbed or reset itself. And so, as a retail investor, which I would be, you would be in this case, we have certain advantages. We have time horizon advantage. We can go deep, although they can go. And I mean, there's some pretty smart guys that are hired to go deep, but they're usually not coming in from domain knowledge, right? And
Right.
so the part of this discussion is when you're dealing with incredibly complex technical products like Tesla's AI offerings or Nvidia chips themselves, what do they do? What are their advantages? You're hiring the wrong people. Like I mean, not saying hire me, but what I'm saying is they should be hiring like um, deep AI computer science guys as their analyst
Yeah.
that could tell them which way is up.
Right.
Because what are they left with? Nvidia's going underwater because DeepSeek, used the resource better. Or Tesla FSD is garbage because now Nvidia has a
Increase.
synthesizing data framework, and suddenly Ford is going to come around and just snap their fingers and have right.
Yeah.
So
Yeah. Exactly.
or throw lidar and then it's a safe system. Otherwise, it really wasn't to begin with. with no concept of the engineering conditions involved in that, or workload or processes. So yeah.
All right. Well, there you have it, folks. There's a deep dive that will give you tremendous amounts of information about these various subjects, and also just a little bit of investment advice, if you will, or lifetime advice. Many decades of experience picking stocks. And later, no, later to this will be late. This is the last show of the night. So earlier today, you might want to go back and take a look at the Monday morning show, which of course is on Sunday night, where we talk about all the stuff that's coming up this week. And it is a chock full week. If you didn't already check that out, I'll put the card right here. Phil Beisel, again, you've done it. You've scored. You've brought me stuff that I wanted to learn, and if I want to learn it, I'm just going to guess that the crowd wants to learn it too. So let's do it again. We'll see you in a future video, and I appreciate you coming on.
Thank you.
All right, and to all of you out there, hey, I appreciate you too, and it's been great talking to you.